Assalamualaikum warahmatullahi wabarakatuh. My name is Daniel Akbar bin Aminuddin. My metric number is S80459. Today, in this video, I will be presenting about my assignment of electrical equipment and measurement. As you can see from our objective, we are here in this experiment. We will be measuring and analyze the voltage, current, power, continuity, resistance, and frequency of an electrical iron. Okay. By using the equipment, which is a clammeter, a digital multimeter, and the electrical iron to measure with, to use as the equipment, and lastly a screwdriver to out any screws that need. Next, we'll be doing the procedure. First thing first, before we power on the electric iron, we'll be measuring the continuity of the iron itself. Next, we'll be once the power is on, we'll be measuring the frequency. By doing it by using the multimeter and connecting it to a parallel, not to the iron but to the socket, to get the frequency of the iron. Next, we'll be measuring the current on different levels, both current and voltage on all different levels of level 1, 2, and 3. Okay. Next thing, we'll be doing a theoretical comparison, which is by seeing the difference of voltage, power, resistance, and current. See the difference of all four of these and see what is the difference between our theoretical and our experimental observation, which we'll be seeing on our next slide. And yes, I forget to add one more thing to say before we go to the next slide. Is how we measure the voltage and current and frequency. For the frequency and voltage, both are the same, which is the way you put the multimeter is parallel. But the difference is the frequency connection of parallel is not on the electrical iron, but it is on the socket. While the voltage, you need to directly put it on the iron, which is blocked by a screw, which you need to first unscrew it, then you can put the multimeter of both red and black on the live and neutral respectively. Next is how did I get the current for for this experiment is by using a clammeter, which is easier to do than using a normal multimeter. By using the clammeter, I just need to hook it on the life of the iron. The next, I'll just put it on different levels. Why did I not do it on both the voltage? I try on all different levels. It's because a voltage for an iron or for an electric iron on different levels are all the same. It is all the same for all. So if it's 240 voltage for the electrical iron, then within level 1, level 2, or level 3, it will all be the same, except the current. The current will be different, as I said again, we will see on the next slide, which is the data table and result. All right, our data and result. The first thing we can see here, our AC frequency we have gotten is 50.04 Hertz, which is not far from what Malaysian use, which is 50 Hertz. Next, our continuity connection. As we can see here, our continuity to life to life is 6.7, neutral to neutral 0.02.9, and earth to earth is 3.4. I could have, removed all the zeros, but I forgot to do that. Okay, next is where I have said before, where we will compare both experimental and uh, theoretical value. All right, first thing first. Um, the basic, which I will put the basic normal, which I put on the level 1 of the node. There's level 1, level 2, level 3 on how hot it can be. So I put in level 1 and then I measure, making it my the base of the value in which we can see the difference of both voltage, current, and power. Which I said before, voltage will not be affected by any of this. So we can see right here. All right. From this, we can see that the voltage theoretical is 240, while the current is 4.167 ampere. The power is 1000 watts, and the resistance is 57.59 ohms. That is the theoretical value. While the experimental value, the voltage is a little tiny bit more higher, as we have learned from class, that my lecturer, that you, doctor, have taught me. The voltage will be a little bit higher from the base 240, which is we can see right here. That is the current, which is not far from our theoretical value, is 4.31. And the power, by by calculating P equals VI, we can get the power of 1061.12 watts. And the resistance I was able to get is 62.9 ohm. All right. Next is the multi experimental data. This is so I can easily show you what the difference between all of these information, all these calculations. Okay, and we can see that from level 1 to level 3, the voltage all stays the same. So that theory that we have researched, that I have researched, is true, that the voltage of a electrical iron will stay the same no matter how much difference of levels, level 1 to level 2 to level 3. And we can see from the current, there's a difference. From level 1 is 4.31, from level 2, 4.32, and level 3 is 4.35, which in turn will change the power from 1061.12 watts to level 2 is 1063.58 watts, and level 3 is 107.97 watts. A little bit strange. A little bit strange. I think it's one. There's a little bit typo right there. It's 1079.7 watts, not 107.97 watts. There's a miss dot right there. Okay, and funnily enough, the resistance that we got is all the same, 62.9 ohm. And we can you can see here the instruments that I use were for voltage is multimeter, the current is clinometer, as I said before, and the power we calculated, and the resistance we use multimeter. Okay, and all of this you can see the thing that I've done. Okay, the measurements, all the measurements here. Okay, after that we'll be going for the discussion, see if there's something for me to discuss or to tell. Next is the discussion, which is there isn't much to tell, which there isn't much for me to explain, since I already said it before. I'll just go through again. Okay. For first thing first, we'll be talking about the tool selection and the function. The function is being used. First is the multimeter, which we'll be using to measure. We will be using the multimeter to measure both voltage and frequency of the electric ion. Next, we'll be using the climmeter with measuring the current. Next, we can see that there's a voltage deviation, which from the experimental value is 246.2 volt, while the theoretical value is 240 volt, with the power scaling difference of 1061.12 watts with a 1000 watts of the theoretical. Okay, and as I said before, there's a behavior change in current, which is from level 1 to level 3 is from 4.31 ampere level 1 to 4.35 ampere level 3, with the resistance measurement staying fixed at 62.9 across all levels. Next, we'll be doing the calculation of error, the percentage error of voltage, current, power, and resistance. As we can see here, we'll be using the base value, which I've set for it is level 1. So by using the formula of experimental minus theoretical per theoretical times 100%, we'll be getting this value of deviation or error percentage. For the voltage, we'll be getting 2.58% error deviation. For the current, we'll be getting 3.43%, and the power error is 6.11%, and the resistance error is 9.22%. And lastly, a notable phenomenon observed during the testing is that the static internal resistance remains exactly constant at 62.9 across all 3 operational levels. Okay, that is all for our discussion. Next will be the conclusion of this assignment. Finally, we have reached the conclusion of this experiment, which I can conclude it is successful in achieving its objective by utilizing a digital multimeter and a clamp-on ammeter to evaluate the electrical parameters of a multi-level household iron. Quantitative analysis of level 1 operation demonstrate the real-world grid voltage fluctuation 246.2 volt against the 240 volt, causing minor upward shift in total operation current and power consumption. Crucially, the calculated percentage error of all key parameters of voltage, current, power, and resistance remains strictly below the standard engineering error tolerance, which is 10%, validating the precision and structure calibration of the testing instrument. Furthermore, static internal resistance remains completely stable at 62.9 ohm, confirming that multi-level thermal adjustments are regulated via cycling internal switching mechanism rather than structural element. Finally, the pre-test continuity logs and implemented isolation protocols verify that all testing was conducted under secure and safe laboratory conditions. Next is the reference, which we can see all my reference that I have gathered here from 1 to 5 by Boyle Lestat, Terjat BL Teraj, AK 2005, Webster JG, Institution of Engineering and Technology, Hughes E. Heidi J. Brown, K. and Smith IM. These are the reference that I have taken to get my understanding of this assignment of mine. That's all for me. Thank you for taking your time to watch my videos and hearing me talk about my assignment. That's all. Thank you.
Audio Jungle.